Now we'll start with a new chapter, non-concurrent force system. Okay, so in this chapter first we need to understand about the concept called moment. So what is a moment? So moment is defined as the turning effect produced by the force on the body, Okay, it is defined as the turning effect produced by the force on the body. The moment, remember, the moment will not displace the body, but it will produce the turning effect, or you can say rotational effect on the body. Okay, now mathematically moment can be defined as it is the product of force and perpendicular distance. Okay, mathematically it is mathematically defined as product of force and perpendicular distance. Okay, so remember, so for example, if you consider, let it be a fixed joint. It is a bar. This is called as bar A. This is and is bar B. If a force is acting here, assume if a force is acting here, if the length of the bar is L, okay, now moment produced by this force at this point A. So moment produced at point A. Okay, moment at point A is equal to what? So you can see here, moment can be defined as product of force into perpendicular distance. So what is the force here? Force is F into perpendicular distance. So this is a force. Now this is a perpendicular distance, right? So into L. F into L is your moment. If the force is vertical, the distance will be horizontal. If the force is horizontal, the distance will be vertical. That is the meaning of perpendicular distance. So product of force into perpendicular distance is a moment. Okay, so for example, if you consider here, so now if the force is acting here, F, let this be point C, let this be point D, let the length be here L1. Okay, let the force here be F1. Now moment produced at point C, due to force acting at point D is equal to how much? Again, what is moment? Moment is force into perpendicular distance. So force is F1 and perpendicular distance is how much? It is L1. So into L1, F1 into L1 is moment produced at point C. Now for here, what is the moment produced at point B? This is for point A. Now for point B, so again force into perpendicular distance. Now force is F, but there is no perpendicular distance. The force is acting exactly at the given point. So that is F into 0, that's equal to 0. So remember, if the force or its line of action, if it is passing through the given point, then the moment produced by that force at that point is equal to 0, because as there is no perpendicular distance. Okay, so this is moment at point C. Similarly, if you consider moment at point D, again F1 and there is no perpendicular distance because F1 is acting exactly at the point D. So again F1 into 0, that's equal to 0. Okay, got it? So moment can be defined as product of force into perpendicular distance. Product of force and perpendicular distance. If the force is vertical, the distance will be horizontal. If the force is horizontal, the distance will be vertical. That is simple. Okay. Now we differentiate the moment, or we can broadly classify the moment into two types. That is clockwise movement and anti-clockwise movement. Clockwise movement and anti-clockwise movement. So you can see here. Okay, so assume that if this is a joint, if the force is acting here, if this is F, if this is L, A, B. Okay, now here joint, let this be C, let this be D, let this be F, let this be L. Okay, now moment produced at point B and point C is 0 because force is acting exactly at the given point. Now moment produced at point A is equal to, and moment produced at point D is equal to, the moment produced at point A is equal to how much? Again, force into perpendicular distance. Force is F, distance is L. So F into L, or you can say FL. Now we differentiate the moment as clockwise movement and anti-clockwise movement. So what is clockwise movement? So imagine an arc from the arrow mark to the given point along the distance. Remember, from the arrow mark, okay, to the given point along the distance. Okay, along the distance, imagine an arc. That means imagine an arc. Now you can see here, is it clockwise or anti-clockwise? Okay, it is clockwise. So clockwise movement is represented as positive sign. Now I can see here, movement at point D due to force F is what? So again, force into perpendicular distance. This is F, this is L. F into L. So this is F into L. Now from this arrow mark, okay, to the given point along the distance, imagine an arc. Okay, if you imagine an arc here, you can see here, it is anti-clockwise, right? It is anti-clockwise. That is negative sign. So positive sign indicates the clockwise movement, negative sign indicates the anti-clockwise movement. So this is clockwise movement and this is anti-clockwise movement. Clockwise movement and anti-clockwise movement. So what is movement? 1 second. Okay. Okay. So what is movement? Movement can be defined as the turning effect produced by the force on the body. Okay, it is generally. So mathematically, movement can be defined as product of force and perpendicular distance. Okay, so in the given example, you can see here, movement at point A is force into distance. So F into L. Okay, force into distance, perpendicular distance. Remember, if the force is vertical, the distance will be horizontal. If the force is horizontal, the distance will be vertical. So here, movement at point C is again F1 into L1. So we classify the movement into two types: clockwise movement and anti-clockwise movement. Okay, so here you can see movement at point A is again what is the movement? Movement is force into distance. So F into L. So from the arrow mark to the given point along the distance, imagine an arc. So it is, you can see here, it is clockwise movement. So clockwise movement by indicated by positive sign and anti-clockwise by negative sign. Okay. Okay, let us consider an example. Okay, so assume that if the force is acting like this. This is the force acting. So imagine it's a line of action here. It is also a line of action. Okay, now let the point here be, let the point here be O1, let the point here be O2, let the point here be O3, let the point here be O4, let the point here be O5, let the point here be O6, let the point here be O7. Okay, okay, now distance to point O1 from this line of action will be, assume that this is D1, this as D2, so acting on the line, so acting on the line here, so let this be D7 and let this be D6. Got it? So force is acting here. These are the points. Okay, now we'll find the moment at this point. Okay, so moment produced at point O1, moment produced at point O1 is equal to, okay, so what is the moment? Moment is force into perpendicular distance. Now force is what? Force is F. F is acting here, and to this point, what is the distance? Distance is D1. So what is F into D1? F into D1. It is a moment. Now how to classify clockwise or anti-clockwise? From this arrow mark to the given point along the distance. So force is acting here. Okay, from this point along the distance, imagine an arc. So if you imagine an arc, it is, what is this? It is anti-clockwise. So negative. Okay. Now similarly, moment at point O2 is equal to. So what is the force acting here? You can see here, force acting or its line of action is F here. Okay, force is F. You can see here, force is F. And what is the distance? Distance is G2. So moment is force into perpendicular distance, F into D2. Now clockwise or anti-clockwise? So force is acting like this. So from this point to along the distance to the given point, imagine an arc. Okay, if you imagine an arc, it is again anti-clockwise. So minus F into D2. Now moment at point O3. Moment at point O3 is equal to how much? Again, moment is force into perpendicular distance. F is acting here. There is no perpendicular distance because this point O3 lies on the line of action of F. So if a force or its line of action passing through the given point, then moment produced by that force on that point is equal to 0. So is equal to 0 because there is no perpendicular distance. Similarly, moment at point O4 is equal to how much? Again, the given force is passing through the given point. Okay, or given force or its line of action is passing through the given point O4, as there is no perpendicular distance. it's equal to 0. Similarly, moment at point O5. Again, you can see here, O5 is here. If you produce the line of action backwards, it is passing through the given point O5. There is no perpendicular distance, so again it is 0 because its line of action passing through the given point. Now, moment produced at point O6. Moment produced at point O6. You can see here, the force is what? The force or its line of action is F here. Distance is D6. So, force into perpendicular distance, F into D6. F into D6. Now, clockwise or anti-clockwise. So, force is acting like this. So, from this point to this point, along the distance, imagine an arc. If you imagine an arc, you can see here, it is clockwise. It is clockwise. So, plus F into D6. Similarly, moment at point O7 is again F into D7. Again, it is clockwise. So, plus F into D7. Simple. Okay. So, always remember, first we'll write the moment using the formula force into perpendicular distance. So, from the arrow mark, okay, to the given point along the distance, imagine an arc. If the arc is clockwise, use positive sign. If it is anti-clockwise, use negative sign. Okay. Okay. Now we'll see this some examples on moment here. So you can see here. Now let us find the moment at point A and B. So here you can see moment at point A is equal to how much? So moment is what? Force into perpendicular distance. So force acting here is 4 newtons. So what is moment? Moment is force into perpendicular distance. So force is 4. Distance is 2. That is perpendicular distance is 2. 4 into 2. That is 8. Right? 4 into 2. That is equal to 8. Right? Now it is clockwise or anti-clockwise. So from the arrow mark to the distance to the given point along the distance, imagine an arc. If you imagine an arc here, okay, if you imagine an arc here, it is clockwise or anti-clockwise. It is clockwise or anti-clockwise. It is clearly clockwise. So plus 8 Newton meters. Newton meters, and moment at point B is equal to 0. Right? And here for this is first example. Now for second, moment at point A is equal to how much? It is 0 because force is exactly acting at the given point. And moment about point B is equal to how much? So again it is force into perpendicular distance. So force is 6. Perpendicular distance is 3. So it is 6 into 3. That's equal to 18. Now it is clockwise or anti-clockwise. You can see here from the arrow mark to the given point along the distance, imagine an arc. So if you imagine an arc, it is clockwise or anti-clockwise. It is anti-clockwise. So minus 18. Right? Now for the third example, let this be A. Let this be point B. Okay. So moment at point A. Moment at point A due to these forces. Okay. So what is moment? Force into perpendicular distance. So first we'll consider phi. So phi is a force. What is the distance? Distance to point A from this point is 1 plus 1 is 2 meter. So phi into 2. Phi into 2. Now it is clockwise or anti-clockwise. You can see, from this arrow mark to the given point along the distance, imagine an arc. So it is, you can see here, it is clockwise. So plus phi into 2. Then we'll consider 4. Now 4 is acting here. Again force into perpendicular distance. So 4, the distance is 1. So 4 into 1. Okay. Now it is clockwise or anti-clockwise. You can see here again it is clockwise. So plus 4 into 1. That's equal to 5 into 2 is 10 plus 4 into 1 is 4. That's equal to plus 14 Newton meters. Newton meter. And moment about point B is equal to. Moment about point B is equal to. So due to moment produced at this point, okay, moment produced at this point due to this force is 0 because this is acting exactly at this point. 0 plus 4 into the distance is 1. 4 into the distance is 1. It is clockwise or anti-clockwise. You can see here it is anti-clockwise. So minus 4 into 1 is minus 4. So this is minus 4 Newton meter. Okay. So we need to find the moment to the asked point. So in the question it will be asked to find the moment at the given point. If the moment is asked for point A, find the moment at point A. If the moment is asked for point B, find the moment at point B. Okay. Now we'll consider another example on the moments. Okay. So here the question is to find the moment about point A due to the various forces acting on the square. To find moment about point A due to the various forces acting on the square. Okay. That means we need to find moment about point A, or you can say summation of moment about point A is equal to what? Okay. So moment about point A is equal to. Okay. So first we'll consider 10 Newton force. First we'll consider 10 Newton force. So moment produced by 10 Newton force at point A is equal to how much? So what is moment? Moment is force into perpendicular distance. Now force is acting like this. Okay, force is acting like this. What is the distance? You can see here, this is a force. Okay, now this force or its line of action, if you produce the line of action backwards, it is passing exactly through point A. Okay, if the force or its line of action passes through the given point, then moment produced by that force on that point is equal to 0, because as there is no perpendicular distance. So due to the 10 Newton force, first I will write here, moment due to 10 Newton force is equal to 0. That is 10 into 0. Next, moment due to 20 Newton force. Moment due to 20 Newton force. So what is moment? Moment is force into perpendicular distance. Now 20 Newton is acting here. So you might produce a line of action backwards. Now actually 20 Newton is acting like this. 20 Newton is acting along BC. Okay, it is acting like this. Okay, even though it is acting at point C, if you produce the line of action backwards, it is acting like this. Now what is moment? Moment is force into perpendicular distance. So let the distance be 2 meters. 2 meters, 2 meters, 2 meters and 2 meters. So moment is force into perpendicular distance. Now force is 20, distance is 2. So it is 20 into 2. Okay, now it is clockwise or anti-clockwise. So from the arrow mark to the given point along the distance is now 2 meters. The force is vertical, the distance will be horizontal. Along the distance, imagine an arc. So from this point or from this point, imagine an arc here. Okay, if you imagine an arc, this is the distance. So if you imagine an arc, you can see here it is anti-clockwise, right? It is anti-clockwise. So minus 20 into 2, it is minus 40 Newton meters. Minus 40 Newton meters. Now moment produced due to 30 Newton force. Again force into perpendicular distance. Now force is horizontal, the distance should be vertical. So 30 into 2, you can see here the force is 30 acting at a distance of 2 meters from the given point. So 30 into 2. Now it is clockwise or anti-clockwise. From the arrow mark to the given point along the distance, imagine an arc. So if you imagine an arc here, you can see here, if you imagine an arc, it is clockwise or anti-clockwise. Again it is anti-clockwise. So minus 30 into 2 is minus 60 Newton meter. And moment produced by 40 Newton force is equal to how much? So 40 Newton is acting exactly at the given point. So there is no perpendicular distance. Or you can say if the force or its line of action is passing through the given point, then moment produced by that force on that point is equal to 0. So again it is equal to 0. So total moment acting at point A is equal to 0 minus 40 minus 60 and 0. It will be 0 minus 40 minus 60 minus or plus 0. That's equal to minus 100 Newton meter. Minus 100 Newton meter. Okay. On the same scale, if you find moment about point B, you can see here. Now I am finding moment about point B. Now first we'll consider again 10 Newton force. So first I will write here moment due to 10 Newton force, 20 Newton force, 30 Newton force and 40 Newton force. Now I am finding moment about point B. Remember, I am finding moment about point B. What is the moment? Moment is force into perpendicular distance. First we will consider 10 Newton force. If you consider 10 Newton force, moment produced by 10 Newton force at point B is equal to how much? Now you can see here this force or its line of action is passing to the given point. Then it should be equal to 0. Next we will consider 20 Newton force. If you consider 20 Newton force, so 20 Newton force, or if you can see here, if you produce line of action backwards, it is passing exactly to the point B. There is no perpendicular distance. So if a force or its line of action passes to the given point, then moment produced by that force on that point is equal to 0. Again 20 Newton force is also 0. Next, if you consider 30 Newton force, so this is a force and this is a line of action of the force. Okay, what is the moment? Moment is force into perpendicular distance. Now this is a 30 Newton force and the distance is 2 meters. So this is 30, this is 2. So 30 into 2. 30 into 2. Now it is clockwise or anti-clockwise. From the arrow mark along the distance, this is the distance. So from the arrow mark along the distance, imagine an arc. Again, here you can see it is anti-clockwise. If you don't understand here, imagine the force here. So again, if you produce the arrow mark here, it is anti-clockwise. So minus 60. Okay, it is minus 60. Now moment produced by 40 Newton force is, again you can see here 40 Newton is acting like this. Okay, if you produce a line of action backwards, it is passing through the point B. So moment produced by that force at that point is equal to 0. So summation of moment at point B is equal to minus 60 Newton meter. Simple. Okay.